Right? This is from 2013, May, June, paper 42 or variant 42. Explain how the hardness of X-ray is controlled by the extracting voltage. Right? We have answered this one. Right? Hardness depends on energy of X-ray. Changing voltage, change the kinetic energy of the electron. Changes energy or speed of electron. Changing electron energy changes the maximum X-ray. That's the X-ray that's produced. Photon. Usually they won't give you this formula lah. Since they are required to recall, but sometimes they may be quite generous. Right? Attenuation, lose in power or lose energy or lose in intensity. Just one of them lah. No need to write all of them. Why the expression applies only to parallel beam? Right? This formula is for parallel beam only lah. Intensity changes when the beam is not parallel. Decreases when the beam is divergent. Okay. Only in parallel, the beam entering the absorber will all be the same value lah. Whereas if it's divergent, it will have different value. Just like a point source that is spread out in all direction. Okay. This is the formula that is given. The linear attenuation coefficient X-ray in bone and soft tissue. That's for bone. That's your soft tissue. Calculate for parallel X-ray beam the ratio of fraction of intensity transmitted to bone of thickness 2.5 to fraction of intensity transmitted to soft tissue of 60 cm. Right, this is per cm, so no need to change. Right, just using this formula. For bone, there's a thickness, that's a attenuation coefficient. Just use this formula, that's all. Right. Then for soft tissue, right, 0. This point are not common, 0.95 times 6. Right, that's a 6 cm. And then give you 0.21. Okay with that?
Yeah.
The rest you can do yourself. And then I'll go over with you on Thursday lah. Rather than I do everything for you, we go to CT scan lah. If got time, we will try to come back lah. Okay. Computed tomography. So we should be able to finish CT scan today. And then Thursday we go to PET scan lah, PET lah. That's the last of the medical physics lah. And after that, topic 25 is the last topic lah. Right, day 301.
Oh, my mock test is actually next week.
Up to 24 only lah. 25 don't have lah.
Oh yeah, I think my teacher said that.
Okay. Quite rush lah. A2.
Has it always been like that?
Yeah, it's always like that. AS got plenty of time, A2 rushing. So we usually don't test everything lah. Okay. This is your anatomy of a CT scan. Right? There's your patient lies on the motorized platform. You can go in or go out. Right? The platform is movable. And there's your X-ray source. Right? Directly below that, rotating X-ray detector. Right? This one, the source, this is the detector, and then direction of rotation, the direction of rotation of the X-ray source. So usually we take a slice of the body and follow another slice. So if we want to X-ray this part, we take a slice and then build a picture of it using program. We build an image of it in the computer. That's why you need a computer lah. Then we take X-ray of the at each slice. We take it at different angle. Anyway, we'll go over it one by one. Right? It is give a three-dimensional image lah. That's why we use CT scan lah. CT scan give doctors a three-dimension view of the body. The image are exquisite detail but require a dose of radiation that can be 100 times that of a standard X-ray. Right? So I exposed to X-ray greater dose in CT scan because it take a picture of different slides at different angle. Whereas X-ray, you just do it once as all. Computed tomography scan are made by rotating the X-ray beam. This X-ray beam is rotating around the patient, imaging the body in a series of slides that are computer stitches or combined together lah. Right? That's why you need a computer. Without a computer, you will not be able to do CT scan. Okay, computed tomography or CT scanning. CT or CAT, scan stands for computerized axial tomography scan. Right? A for axial. The scan uses X-ray and a computer to create detailed images of the inside of the body. Right? The advantage is three dimension, and then you can observe it. It gives you a depth, and then you can observe if there's a tumor there, you can observe from different angle. Okay, CT scanning. CT scanner is a large ring-shaped machine. The X-ray scanner inside the ring. Right? There's an X-ray source. Rotates in small movement around the body as you lie on the bed that move backwards and forward. Right? This bed can go forward or backwards through the ring. As you move through the machine, the scanner uses a series of X-ray beam to scan parts of your body and build up detailed images. The images produced by CT scanning are called tomogram. They are more detailed than X-ray, standard X-ray, which use a single beam of radiation and can give views of structure inside the body, including internal organ, blood vessel, bones, and tumors. That's the advantage. We want to see where's the tumor exactly. There's the arrow. Indicate a collection of blood between the skull and the outer covering of the brain. This is a CT scan image of the brain. Contrast material injected into the vein during CT scanning of the head highlights the tumor in both sides of the brain. It's a tumor. We use contrasting material. The CT scan can be used to diagnose or monitor many different health conditions, including cancer and bone disease. It's often used to provide views of your body before another procedure takes place, such as a biopsy or radiotherapy treatment. Give a picture of CT scan, give a picture of what is happening and then what is the next step to do. CT scan is painless, don't feel any pain, and usually takes about 10 to 30 minutes, which is quite long compared to X-ray, depending on which part of the body is being scanned. Right, memorize this one. No? Briefly explain the principle of CT scan. Right, this one came out in 2010, May, June, paper 41. X-ray taken off a slice, right, like a bread slice, repeated at different angle. Right, these are all different marks. They will give you. Images is processed, combined to give 2D image of the slice. The procedure is repeated for successive slice to build a 3D image. Image can be viewed from different angle. That's the advantage. You can see where is a tumor at different angle, right? More clearer. Whereas X-ray is only one slice only. Right? Memorize this one. No? That's all. That one, it is for info, just to give you some idea. Right? We break the body into different volume called voxel. Image of a slice of a tissue divided into volume element, voxels, and attenuation in each voxel determines the brightness, shade of gray, and the corresponding pixel. The final two-dimensional image, right? Two-dimensional of the slice. This is removed from the syllabus already. So a lot of things have been removed from the syllabus. Aim of CT scanning is to make an image of a section through a body for measurement along the axis. Right? That's the axis. Straight through the center there. The section to the body is divided into series of small volume called voxels. You divide into small volume of the body section that you are looking at. And then you measure the intensity called the pixel. Image of the voxel would have a particular intensity known as pixel. Pixel is built up from measurement of X-ray intensity made along a series of different directions around the section of the body. Right? As I say, we won't bother about all these terms. Don't bother. Just for info. Comparing X-ray and CT scan. X-ray image involves a single exposure, for CT scan exposure of the slice from different angle. Repeat for different slice. Thus, CT scan involves a much greater exposure to X-ray. Okay, remember?
Teacher,
Okay?
teacher,
Yep.
can I say CT scan reflects while X-ray penetrates?
Say again.
Can I say CT scan reflects while X-ray penetrates?
It doesn't have to do with penetration. Whereas X-ray is you just take a picture of the whatever, like you want in look at the chest, you just take an X-ray, that's all. Whereas CT scan, you rotate the X-ray source at different angle, and then you use the detector and create an image of it on a computer.
Oh,
So you
yeah, I think I mixed up with ultrasound.
ultrasound, you also do it can create three-dimensional image, but you are not interested in that. You're interested in I think basically interested in the how to calculate the distance of the different parts as well. And then the attenuation, that's all. Okay. Any other comment?
No.
Distinguish between images produced by CT scan and X-ray. Same, no different. CT scan, thin slice through structure built up from many slices to form 3D image. Each slice is built up from many images at different angles. X-ray image, shadow image of the whole structure, giving a 2D image. That's all. Memorize all of them. By reference to principle of CT scanning suggests why CT scanning could not be developed before powerful computers were available. X-ray image of slice taken from different angle. Right? You want the image, and then you want to build up the image of different slice. These images are combined and processed. These are repeated for different slices. The slices are combined to build a 3D image. 3D image can be rotated. Computer required to store and process huge quantity of data. Right? So you need a computer program. Nothing much to teach you, just memory work. In practice, the image of each section is built up from many small pixels, each viewed from many angles. Collection of data and its construction into a display on the screen requires powerful computer and complicated program. Right? This one has been removed from the syllabus. How you do it with the numbering there. In fact, the reconstruction of each pixel intensity value require more than 1 million computation. You can see that computation is required. The contrast and brightness of the image section can be viewed on the TV screen, can be varied to achieve optimal result. Right? You got a control of the contrast and brightness of the image on the computer screen. In order to build out an image of the whole body, the procedure will be repeated for further section to the body. All data of all the section can be stored in the computer memory. You can see that the need for computer to create a three-dimensional image. View from the body from different angle may be constructed. Okay. Any comment?
Yeah.
I think we have more or less completed. Let's try to see what are the questions that I encounter. Right, this is 2010 October, November, paper 43. An X-ray image is taken of the skull of a patient. Another patient has a CT scan of the head. By reference to formation of the image in each case, suggests why exposure to radiation differs between the two imaging techniques. You want to try first before I give you the answer?
I don't know the answer.
Basically, X-ray is just one shot. Like you fire a gun as well. You take the X-ray of the region that you are interested in. Whereas CT scan, you take it at one place and then you change the angle, a different angle through a slice of a body, and then different slice. Okay, let's look at the answer. X-ray image involve a single exposure, while CT scan exposure of a slice from many different angle repeated from different slice, right? Each slice at different angle, you repeat the same procedure with different slices. That CT scan involve much greater exposure to X-ray, right? All these slices you build up to get a 3-dimension of the section, no? Right? These are distinguished between images produced by CT scanning and X-ray. Same thing, no? CT scanning, thin slice to structure built up from many slices to form a 3D image. X-ray image, shadow image of the whole structure giving in 2 dimensions. By reference to principle of CT scanning suggests why CT scanning could not be developed. I think we have gone over that already. Right? So I just give you the answer. Anything, any comment, anything not clear?
No, that's all right.
CT scan, you have to take the image instead of on the photographic paper, you have to build the image in a computer. So you need a computer program. And each time you take an image, the image is, the program has to tell you how to do it, how to add a different intensity together at different angle to build up the image of the section of the body. The intensity of X-ray is reduced to 1/2 of its initial intensity when it passed through a bone of thickness 0.4 cm. Calculate the thickness of the bone necessary to reduce the beam intensity to 1/10 of the initial value. Can try. Try. This is more complicated other than direct. Basically, this is a formula you need to remember. X is given. X is given. That's your X. Then I naught and given. Right? Half. Fraction is half. So from there, you can calculate your mu. Right? Or using the formula. You don't have to use the formula. This one doesn't require to use formula. If you know how to use it, go ahead. Use the formula. If not, use this equation. Same thing. Right? Then 1/10 fraction to 1/10. Calculate the thickness of the bone necessary to reduce a beam to intensity to 1/10 of the initial value. So you calculate again. Right? First, you calculate the attenuation coefficient from this part there. And after you have found that, you just use this formula. Right? Basically, you're using this two formula twice. If you know this one, use it. If not, use this one twice. Right? Where I know is half. The first one. That's why you get this equation. Can. Anything not clear?
Yeah, I'll just sum in the formula.
Getting used to use the formula, that's all. Try this one. A parallel beam of X-ray photon is produced by X-ray tube with 80 kilo electron volt across it. The beam has intensity reduced to 1/2 of its original value when it passes through a thickness of 1 cm of copper, 1 millimeter of copper. Describe the energy of the X-ray photon in the beam. This one, it won't come out lah. If come out, you have to describe maximum energy of photon is 80 kilo. Right? This is the energy. Right? This energy, 80 kilo electron volt. And below is a continuous spectrum with sharp spikes. Right? As I say, you just need to give the maximum energy is 80. And then the wavelength is where all the energy is given to the minimum wavelength is where all the energy is given to produce a photon of X-ray. Okay, you don't need to know about continuous spectrum. You can say continuous spectrum. Don't need to know about sharp spike. No? It's a continuous spectrum. Remember, energy can be given to produce the X-ray from minimum wavelength to any value, minimum to the highest value possible. Because the electron can give either all its energy or different part of the energy. That's why it called continuous spectrum. Okay or not?
Yes.
A parallel beam of X-ray photon is produced. Okay. Determine the linear coefficient mu. You either know this formula, right? Either use this formula or, as I say, use the main formula, right? They have given you. Right? Use this formula. Don't need to use this formula if you don't know. You're not required to know this formula. And then you will get this step. Suggest with reason the effect of linear absorption coefficient if the beam is comprised of 100 kilo electron volt instead of 80, we use 100. Yep. Suggest with reason the effect of linear absorption coefficient if the beam is comprised of 100 kilo electron volt. Any comment for your answer? Any thought?
Difficult.
It will affect the linear absorption coefficient because it's more penetrating, more energy. For large energy, X-ray is more penetrating, so mu is smaller. Okay.
Okay.
Quite popular lah. This one question you come out. Right? So memorize it. Right? 5-mark question. Okay. A student investigate the absorption of X-ray radiation in the model arm. A cross-section of the model arm is shown. Right? That's the bone. That's a tissue or muscle. Parallel beam of X-ray are directed along the line XX, along the line BB. Linear absorption coefficient for the muscle and for the bone is 0.2. Right? This is for the muscle. This is for the bone. Bone tend to be larger. Okay, calculate. Calculate the ratio or intensity of X-ray beam on the model to intensity of X-ray beam on the model. And it means before, after it leaves the model, and then before it enters the model for the X-ray beam directed along the line MM. Can mm is ACM, is muscle, so you use this one. You should remember the formula. Can get the answer? Right? Use this formula. Right?
Oh yeah,
Simple.
okay.
I or I not lah. So mu is
HCM.
0.2, and then this is ACM. Try for BB. Same formula, that's all. That's why be careful with your X and mu, that's all.
BB is 4 cm, right?
Bone is 4 cm. Muscle is also 4 cm. Attenuation in muscle and bone. Okay. This is multiply. Okay. One is for bone, one is for muscle, one is for bone. And then both of them 4 cm. So it's very small,
Okay.
very small, almost approximate to zero. Can. Any
Oh yeah,
comment?
yeah. Okay, I get it. I
Right?
get
Bone
it.
is 4 cm. Muscle is also 4 cm. No? 8 minus 4 is
Because
4.
the first one is just muscle.
The
The
first one
first one
is,
is just muscle only.
say again.
The first one is just muscle only. The next one is
Muscle, that's why ACM.
half
No?
muscle, half bone.
Then this one half muscle, half bone. No? BB. Okay, state whether your answer would indicate the X-ray image has good contrast. Yep. Sharpness, they won't ask you lah. But has it good a good contrast? Yep.
What's the good contrast?
Contrast is different of blackening and white and black pages. So you can see clearly. No? You got different attenuation
Yes.
coefficient. No? Contrast good. Oh yes, region of bone and muscle can be distinguished. There's good contrast. No?
What's an example of bad contrast?
Say again.
What's an example of bad contrast?
That contrast to be if you have muscle and other tissue. Bone and muscle, it will be good contrast because both have different absorption coefficient. No? You look at, that's the reason why they ask you to calculate. Okay? There's your bone, complete absorption. There's your tissue, muscle. So you can see clearly the bone and the muscle. Whereas if it's muscle and other soft tissue, the contrast will be poor. Because the attenuation coefficient is almost the same. Okay, now.
Yes.
Okay, I think I won't start. I leave you the rest of the time. We still got about 2 minutes. Any question you have to ask? So you have to decide
Don't have.
whether you want to have 5 o'clock on Thursday or
Yeah, sure.
or at night, 9 o'clock. So you decide. Lor.
I prefer at night.
Say again.
Actually 5 o'clock. Yeah, 5 o'clock.
5 o'clock you can have two sessions, 2 40-minute sessions. And if we can finish that this is the last topic already for medical physics. After that is astronomy and cosmology. That one will take only one or two 40-minute session. No? Anything you want to ask?
Okay. No.
Okay, no? Then we will have an early day, no? Less than 1 minute, about 1 minute left. Lah. If you got
Okay,
no
thanks.
question to ask, I will end now. No?
Okay, thanks, Joe.
Okay, I see you on Thursday then.
Bye bye.
Bye bye.